Hello, everybody. Welcome to our Scatterplots and Correlation notes. This is going to be really quick and hopefully a review from something that you may have seen in the past. So a scatterplot is when we have, yes, it looks like a graph, and we are going to plot points on that graph and see if they are related to one another. So that's what correlation means. Are those two things correlated in certain ways? Like, as if one thing goes up, does another thing go down? Are they unrelated at all? We're going to basically look at the relationship between two sets of data to determine whether or not there's any kind of correlation. Okay, this is something that you will see on the PSAT, the SAT. You will see it when we read publications, all kinds of things. So that way you can analyze what you're seeing graphically. Okay, all right, so for the first blank, it says a blank, and you're going to put right here a scatter plot. Has points that show the relationship between two sets of data. So this first example right here, it says use the table below to make a scatter plot on test grade versus homework grade. So my question to you, without actually plotting this data, is do you think, like, would we hypothesize that we would tend to have higher test scores for higher homework grades, or the more times that we complete our homework? Well, I would hypothesize, being a teacher and having seen many classes, and having gone through my own classes, that if you do your homework and you get a good homework grade, my guess is that you would probably get a good test grade. But let's actually find out according to this data. Okay, so on this particular graph, I want you to label, let's see, this is our y-axis, okay? This is going to be our test grade on this side. And then on our x-axis, we are going to have our homework grade, okay? And what I'm going to do is I'm going to start out where this is 0, so 0, 0 at our origin. And every, let's see, line is going to be worth 10-ish. So let's say we've got 10, I'm just going to leave every other one 40, 60, 80, 100. So the goal is to get 100 on your test, right? Let's do the same for our homework. 20, 40, 60, 80, 100. Please note that the line in between is, our 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, but we're not going to write them all in. Okay, so let's start analyzing our data. And what I'm going to do is I'm going to first look at our homework grade. It says 94. Find that. Let's see. So our homework grade is going to be, here's 90, 94, somewhere in here. Okay. And actually, I'm going to do this so that it makes it easier. Here's your X. Here's your Y. Okay. And if our homework grade is somewhere around 94 right here, we're going to go all the way up until we hit about 98. All right. So our plot point is going to be right about here. So make your first point right there. Okay, it doesn't have to be perfect, but pretty close. All right, so we've got that one. Let's do 65 and 67. So I'm going to go here to 65, okay, and then go up to 67. It's going to be somewhere right in here. I'll show you. 65, I'm going to go straight up to about 67. Remember, this is 70 here, so somewhere in the halfway point, okay? All right, so we've got our second data point. Our next data point, 82 on the x-axis, find that, and then go up from there to 78. So we're somewhere right in here, okay? 79 is our homework grade, and 96 is our test grade. So let's see, 79, and then 96. Ooh, this person did pretty well. Okay. Let's see, 82 and then 85. I'm going to go over to 82 and up to 85. So right about here, 75 and 73, 50, 60, 70, 75 and 73, somewhere maybe right here. Ooh, 20 and 40. Okay, so 20 and 40 would put us right here at this dot. 95 and 94. Okay, so I'm going to go over to 95 and I'm going to go up to 94, somewhere right here. And the last one is 75, 88. 75, 88, somewhere right here. Okay. Once you get all those, you can see we kind of have, I don't know if it looks like a line or anything, but we could, sometimes you'll see this on your Alex, estimate a best line of fit. Okay, so I'm going to use this as my starting point, kind of imagining. Can you imagine there's a line going in this direction? That's kind of what we're seeing, right? And I imagine that if we start to get more data points down here, we were to, say, examine 3 or 4 classes, we might see a stronger correlation, okay? You might start seeing something like this, you know, and more lines or dots coming together. Okay, so that's looking at a scatter plot. All right, so let's sketch an example of some scatter plots down here. You're gonna have something that looks like this in each of these areas, okay? So give yourself plenty of space. But when we're looking at scatter plots with a strong positive, okay? So here's your y-axis, here's your x-axis. Go ahead and label those, y, x. I'm gonna give you an example too. A lot of times x is time. In fact, if you see time, it is always on your x-axis. And say y is sometimes money, okay? Or height, or weight, or number of shoes, or whatever, okay? So not always, but like the example above is not always the case. But when you see time, time is always on the x. All right, a strong positive correlation might look something like this, where you have data points that basically go up. So what this is saying, so we've got lots of data points here and they are all very close together, okay? What you're saying is that as time increases, so does whatever is on your y-axis. So money also increases, or the height also increases, or the weight also increases. Okay, so that's a strong positive correlation. Now, a strong negative correlation, let me see here, I'm gonna do this. A strong negative correlation, I want you to draw another graph here, okay? And here you have your y-axis, your x-axis. A negative correlation is going to look something like this, where we have data points that go in the other direction, okay? It's going to be very easy to see something that would go this way. So as time gets higher, whatever this is goes lower over time. Okay, so you can see this is a negative correlation and it's very strong. We say it's strong because we have a lot of data points that center around this imaginary line, okay? Now, what if we have a situation where there are two things we're looking at that are not correlated whatsoever? So something silly might be like, I don't know, we have your age on one, so time and age on the x-axis, and I don't know, the number of snacks you like to eat on the y-axis, okay? A no correlation might look something like this. We just have, and I want you to draw these in here, okay? We have nothing that looks like anything, and you just have kind of data everywhere. Right? You could be 98 years old and like 5 snacks, but you could also be 10 years old and like 5 snacks, okay? It doesn't matter how old you are, there's no correlation to how many snacks you like to eat. Okay, let's look at a weak positive. Now, a weak positive is going to be something very similar to your strong positive, except it's going to be a little harder to tell. So you're going to still see data points kind of in the same direction, right? But the data is going to be more spread out like this. So you're going to have different points, but it's not going to be so tight together. Okay, and you may even have like one way off here, an anomaly, right? But in general, you can kind of see there is a positive correlation. It's just not as strong as something with data points very close to the line, okay? And then same for a weak negative. So if you're gonna draw a weak negative, you're also gonna see the same thing as your strong negative, but again, we're kind of not necessarily on this data point, and we can have some that are out away from this line, and we're just gonna make a guess. They kind of generally go in the negative direction like this, okay? All right, so let's be creative. Let's think of an example. If you would, think of an example of something that relates two variables to each other and then classify it. Is it positive correlation, negative correlation, or no correlation? Kind of like the examples I gave you above. Your answers are gonna vary, so come up with something. And then what I'd like to do is after the notes are over, I want you to come up to me and let's talk about your example. Okay, so my example is going to be something simple like, and I don't want to see the same example, so this is you coming up with your own example. So my example is going to be, let's see, how about the temperature outside and the amount of time the heat is running in my house. So I'm going to say the temperature outside and amount of heat. So you are not copying this down. You're kind of thinking of your own. I just want to give you an example. Heat, the amount of, time heat is running in my house. So if you need to draw it, please draw it. But I mean, I might think it's something like this. So let's see, the temperature outside, time is this, right? So this is my degrees. Degrees are on this side. So if the temperature is really, really cold down here to 0, do you think I'm going to be running my heat a little bit longer? I would say yes. So let's just say this is my temperature is 0 degrees. Oh, I'm probably going to be running my thing way out here, right? But then if it's 0, I'm gonna be running it for longer, right? But then say it's 100 degrees outside and it's way up here. Am I gonna be running it for very long? It's probably gonna be close to 0, right? And so forth. So I might see something like this. So I would say that this would be a negative correlation, right? Okay, because as the temperature outside increases, you're gonna use your heat less in your house, all right? So think of something that could be positive, negative, or even no correlation, that's fine too. But I want you to be able to explain it to me, show me a little diagram like that and see what you come up with, okay? Okay, that is it for notes. When you're done showing me your example, I'm gonna go ahead and give you the homework for today. And then after that, you can jump on Alex and you'll be all done, all right?